Hey guys, Mr. King here. Today we're going to talk a little bit more about atoms, but we're going to talk about what's inside the atoms. Now you got a little bit of an idea last time from that video you watched about how big an atom is and how there are different things that are pretty small sized in it. Today we're going to talk about how those things were discovered and how they make up the different parts of the atom. So we're going to be using a big word called subatomic particles. But if you break it down, sub just means inside, like submarine means inside the water, marine means water. So subatomic means inside the atom. And so these are the pieces of things inside the atom that make up the atom. Once again, how big is an atom? They're tiny. If you took all the atoms from a grapefruit and blew them up into the size of blueberries, they would fill the entire earth. Okay, so there are these really, really tiny things that if you made the size of a blueberry, they could fill our entire planet. Okay, so that gives you an idea of how tiny they are. So there was the first subatomic particle that was discovered. The first time someone said atoms are not the smallest thing. There's something inside atoms that are even smaller. This is called the electron. J.J. Thomson discovered that atoms are made of even smaller subatomic particles, and they're called electrons. And not only are these little things called electrons, they have a negative charge. And the way he figured this out is he had this cathode ray tube and he shot this beam through, and if the beam had no charge, it would have just gone straight through. He had some magnets on the top that were going to change the field if it had any charge at all, and it moved. And he said, whoa, that wasn't supposed to do that. It was supposed to just go straight through. But because it moved when it got by the magnet, that meant it had a charge. Now, you guys have all played with magnets before, and you know when you flip them a certain way, when you have them being opposites, they attract to each other. When you have them being the same, they do what's called they repel. And you try to like push them together and you can't, and when you let go, they kind of fling off into the area. That's what happened. He thought there would be no attraction. He thought the tube would just have a beam going straight through, but it didn't. And that showed that atoms were made up of more than just the empty space they thought. They thought the atom was the smallest thing. There's actually electrons in it. So here's what Thomson thought. He thought since most things are neutral, that means like when you go up you don't get a shock from it, it's not carrying a charge. He thought it was this ball of positive charge with electrons embedded in it. And you can see there's a picture down there, that big plus sign means it's positive. And those little negative signs means it's negative. If you take a positive and a negative, it'll cancel each other out and make it neutral. And so that's what he believed the atom looked like. And that made sense because that's all they knew was inside the atom. They just thought it was a bunch of electrons and then it had a positive charge, so they would equal each other out. So this is kind of the first step. Okay, J.J. Thomson discovered atoms are not the smallest thing. There's something even smaller. Next, this guy named Ernest Rutherford discovered that not only are there electrons, and you can see in the diagram down here on the bottom it says negative electrons, there is a positively charged center of each atom. So we found out there's this big space in the middle of the atom that has this stuff gathered in it. He called the center of the atom the nucleus, and he found out that the nucleus had a positive charge inside it. And it was positive because inside the nucleus there were these little subatomic particles. There's that word again. Remember, that just means inside the atom. So there were these little subatomic particles that had a positive charge called protons. So instead of what Thomson thought, you can see how Thomson thought the whole atom had a positive charge and then there were just these negative electrons embedded in it. Look what Rutherford's thought. It's different. He thought it just has a positive center, just a really small space in the middle has a positive charge, and then all around it you have these negative electrons. And once again, those would cancel each other out. So you can see there's a bit of a change in the model. Okay, he's got no nucleus, just this big positive ball. And then Rutherford says, no, there's a center part to this atom. We're going to call it the nucleus, he said. And inside the nucleus, there are these little subatomic particles that have a positive charge, and those are called protons. You can see the electrons are scattered around the space, and it's empty space around the nucleus. You can see there's lots of open area where there are not electrons. And that area is called the electron cloud. And we'll talk a little bit more about that in just a little bit. So you can see the atom model has changed a ton. Okay, now they're getting more and more information. Now, look at it now. It's even different. Because James Chadwick was actually studying with Rutherford. He was kind of like his student teacher almost. He was doing some research for Rutherford, and he was just out of college. And Chadwick did some more experiments on his own that said, I think there's more stuff in the nucleus. And he was right. There was more in the nucleus than just protons. There were neutrons. And this was even more difficult to discover because neutrons have no charge. They're neutral. So if you pass them by a magnet or a charge of any sort, they're not going to move because they don't have a charge. But this is kind of our modern day atomic model. This is what we think it sort of looks like. You've got in the middle, you've got two different colored subatomic particles. You got blue and orange. And those are going to be your protons and neutrons. Okay, so inside the nucleus, you're going to have two types of subatomic particles. You're going to have protons and neutrons. And then surrounding it, you're going to have those electrons. Now, those electrons aren't really on those little spheres like that. They don't really make orbits like that. They're scattered out in space. But this is most commonly what we see with a model, and it shows how the electrons can be arranged in order to make it a little bit easier to understand. Okay, the electron cloud is actually this huge area around the nucleus. So this, once again, is not drawn to scale, but it's easier to understand this way. So if in the nucleus you have protons which are positive and neutrons which have no charge, the nucleus has a positive charge. And then you've got electrons surrounding it that have a negative charge. So you have a positive center and you have a negative outside, and those cancel each other out. And that's why most things in the world are neutral. Okay, they have both positive and negative charges to kind of cancel each other out. So this is what the model looks like today as we study it. Makes it a little easier to understand. Once again, it is not drawn to scale, but this allows people like you and I to understand, okay, this is basically what it looks like. If I take you down the discovery timeline, this is back in 1906, so we're talking over 100 years ago. J.J. Thomson discovered the electron. This was kind of the first step in discovering that atoms are really not the smallest types of matter. There's even smaller things inside the atom. We go a couple more years. Then we get Rutherford. Rutherford discovers the nucleus. So he was the guy who said, oh, there's something inside the middle of an atom. That's called the nucleus. And he discovered that inside the nucleus, there's a positive charge. And those little subatomic particles with a positive charge, those are called protons. James Chadwick discovered the neutron shortly thereafter. Okay, once again, we're talking about back in 1910. And remember, they were working together. Rutherford was kind of like the teacher, and Chadwick was kind of the student, which makes this pretty cool that he discovered that when these trained scientists really couldn't figure out. Chadwick came along and said, I think I can figure this out, and he did it, which was a great step for him as a scientist. So he discovered that in the nucleus, there's not only protons, there's neutrons as well. Okay, and that was right before 1911. In 1920, there's this guy called Schrödinger, and he discovered that these electrons, and remember, Thomson discovered the electron, but this is way more specific about how they move. Okay, so instead of them being on these rings like you often see, Schrödinger discovered that the electrons float around the nucleus in a space called the electron cloud. And they're not in any specific order, they're just kind of free to roam. And as we'll discuss, electrons can actually go from one atom to another. When you are shocking someone, if you guys have ever rubbed your feet on the carpet and then walked up and touched your little brother or sister because you love them so much, that's a shock from having extra electrons. You're actually stealing electrons from the carpet and putting them on your body. And then your body wants to get rid of them as quick as possible, so it shocks whoever it is. Okay, so a shock is actually a bunch of electrons that you stole. And we'll talk more about that later this year. So you get an idea kind of everything that has happened in the discovery of the atom. And it went from way back in 370 BC to Democritus saying, I think everything is made of this tiny stuff called atoms, to now we've got a pretty good idea about all the things that make up an atom and their insides. And now more research is being done, and we've discovered that even protons and neutrons and electrons are not the smallest thing. Inside of them, we have different particles called quarks, and those quarks come in different types. And guess what? If they figured out that quarks make up protons, electrons, and neutrons, there's probably going to be some things that make up quarks. And so it's just going to be, how can we figure out what really is the smallest thing that makes up matter? And that gives us a great idea about how things are made. So hope you guys are getting this. We're going to do a lot of work in class. Like I said at the beginning of the last lesson, it's kind of confusing because these things are really tiny. But we'll get a good understanding of it from some different labs and activities that we'll do. Hope you guys have a great night. Make sure you write some real good questions. These are good ones to think about, and these should be some good discussions in class tomorrow. Have a great night. I'll see you guys tomorrow.